Today I am going to take a topic on galvanic cells. So you are familiar with the galvanic cell, and the galvanic cell is included in +2 syllabus, then BSc syllabus, BSc final year chemistry syllabus, and also in BSc physics syllabus. So what do you mean by galvanic cell? So the answer I will get it as galvanic cells are devices which can convert chemical energy into electrical energy. So I got to ask another question. What do you mean by what is the difference between a galvanic cell and a generator? Or generator is a galvanic cell. In generator, hydrocarbon, that is petrol or diesel, it is a hydrocarbon. The hydrocarbon is converted into burned. That means an oxidation is happening, a chemical reaction is happening. It is converted. That chemical energy is converted into mechanical energy. This mechanical energy is converted into electrical energy. So chemical energy, thermal energy, mechanical energy, and electrical energy. So we are starting from the chemical energy, and our output is electrical energy. So chemical energy is converted into electrical energy. But we all know that the generator are not galvanic cells. So what do you mean by galvanic cell? So you have to modify the definition of galvanic cell as the galvanic cells are devices which can convert chemical energy directly into electrical energy. So we can start from our, we can take a beaker, and I am taking a copper sulfate solution into this beaker. So this is a copper sulfate solution, and I am putting zinc into this copper sulfate solution. So this is zinc. So when we put zinc into copper sulfate solution, these are the reaction happening. So we can see that the zinc goes into the solution, and some amount of copper will be deposited over this zinc, and you can see that the color of the copper sulfate decreases. And these are the reaction happening. The zinc is undergoing oxidation, that is zinc gives zinc 2 plus 2 electron, and in the case of copper is in 2 plus oxidation state. CO2 plus gives plus 2 electron gives Cu. So that is zinc is undergoing oxidation and copper is undergoing reduction. And we can see that the overall reaction is there is a chemical reaction is happening. And when we observe, so the first observation we have already mentioned that in the first observation, the color of the copper sulfate diminishes. The copper will be deposited on zinc rod. Then the third observation is that the temperature of the system increases. And here what is happening is the chemical energy, the chemical reaction happens, and this chemical energy is directly converted into thermal energy. So we are tapping this chemical energy, and we have to convert this chemical energy into electrical energy. So we have to prepare a device which have to convert this chemical energy directly into electrical energy. So such devices are called a galvanic cell. So in your +2 syllabus you have studied a simple galvanic cell. That simple galvanic cell is nothing but it is Daniell cell. So consider a Daniell cell. So we already mentioned that we are going to prepare a Daniell cell. So this is a picture of Daniell cell. In this Daniell cell, we are preparing by putting the zinc in zinc sulfate solution and copper in copper sulfate solution, and we can see that we are connecting using external wire. So here there is no temperature increases happen. That means electrical energy is not converted into chemical energy. Electrical energy is not converted into thermal energy. But we can see that in this figure we can see that this chemical energy is directly converted into electrical energy. So this is an example of galvanic cell. So galvanic cell is a cell which can convert this chemical energy directly into electrical energy. And we already mentioned that in the case of zinc is undergoing oxidation, copper is undergoing reduction. So what do you mean by oxidation? So oxidation is actually the loss of electron, and reduction is the gain of electron. So we can simply remember this oxidation and reduction using a simple two words, that is oil rig. You are familiar with oil rig. So that is oxidation is loss of electron and reduction is gain of electron. So in this figure we can see that the zinc is undergoing oxidation. That is oxidation is loss of electron. Zinc loses electron. So zinc is undergoing oxidation. In reduction, the copper is gaining electron. So this copper is undergoing reduction. So we can simply remember this oxidation and reduction using this word. So generally in the case of Daniel cell consists of two electrodes. One is anode and another is cathode. One is anode, another is cathode. In anode always oxidation is happening and cathode always reduction happening. So in anode, our anode is zinc is dipped in zinc sulfate solution and cathode is copper is dipped in copper sulfate solution. So anode is undergoing oxidation. That means our reaction is zinc gives zinc 2 plus 2 electron and cathode is undergoing reduction. So that means this cathode copper is in 2 plus state, Cu2 plus 2 electron gives C. Then overall cell reaction, so we can add this reaction, and if there is any common term in left hand side and right hand side we can cancel it out. So in this equation we can see that the 2 electron is common in left hand side and right hand side, we can cancel it out. So when we are adding, this reaction is zinc plus Cu2 plus gives zinc 2 plus C. So in anode there is oxidation is happen, in cathode there is reduction happen, and the overall cell reaction is the zinc is undergoing oxidation, the copper is undergoing reduction. So this is the overall cell reaction and this is the chemical reaction happening. In this chemical reaction is directly converted into electrical energy. So Daniel cell is an example for galvanic cell, and in that galvanic cell the chemical reaction, this is the chemical reaction, and this chemical energy is directly converted into electrical energy. How we can represent these galvanic cells? So we already mentioned that in the case of Daniel cell, zinc is dipped in zinc sulfate solution, copper is dipped in copper sulfate solution. So we can represent that zinc is the anode and copper is the cathode. The anode is represented as the metal first, then a vertical slash, then metal ion, zinc 2 plus. If there is concentration, you can represent the concentration. Then if there is salt bridge, the salt bridge is represented as double vertical line. And then in the case of cathode is represented as first metal ion, then you have to represent the concentration C2 and then metal. So in order to represent a galvanic cell, first you have to write the anode on the left hand side and cathode on the right hand side. So first in the case of anode is represented as zinc, then zinc 2 plus, then in the case of cathode it is represented as copper 2 plus, then copper. Then how we can write this reaction? So in order to write this reaction, very simple, you can take it from this representation. So you have to take the zinc and anode is undergoing oxidation. So you can represent it as zinc 2 plus 2 electron. In the case of cathode the copper is undergoing reduction. So you can write it like this: copper must be on the left hand side, Cu2 plus 2 electron gives C. So this is the representation. Then we have already write the overall cell reaction. So next we can represent another cell, that is iron copper cell. So in the case of iron copper cell, so iron is on the left hand side, Fe slash Fe2 plus, you can write the concentration, any concentration you can write. Then there is salt bridge, then iron copper cell, so Cu2 plus slash C. So in order to write this reaction of anode and cathode reaction, you have to take this anode first, that is Fe gives Fe2 plus 2 electron. Then you have to take the cathode reaction. So this is anode reaction. So this is cathode reaction, that is Cu2 plus 2 electron gives C. So the overall cell reaction is, so you can write this 2 electron. So the overall cell reaction is Fe plus Cu2 plus gives Fe2 plus C. So very simple, we can write the reactions, the anode reaction, cathode reaction, and overall cell reaction. So if you have a reaction, how you can write the cell representation? So you have a cell that is, so you can represent it as aluminum, then aluminum and copper. So or aluminum copper cell. So in aluminum copper cell, the cell represents, so the reaction is Al. So aluminum is undergoing oxidation, that is Al gives Al3 plus 3 electron, and in the case of copper is undergoing reduction, that is Cu2 plus 2 electrons gives Cu. So you can represent this cell. So this aluminum copper cell can be represented as, so first anode must be come on the left hand side, that is Al vertical slash Al3 plus, then if there is solid bridge you have to represent like that, then Cu2 plus slash C. So if you have the electrode reaction, you can represent the cell, and if you have a cell representation, you can write the cell reaction, that is anode reaction, cathode reaction, and cell reaction. So in this way we can represent a galvanic cell, and we can write the anode reaction, we can write the cathode reaction, and we can write the cell representation.